Thank you for the introduction. I'm Nakamura from Valuenex. Joe Joy was supposed to be here to speak, but the flight was not going to make it. I learned yesterday morning, and I had to solve the combinational optimization problem, whether to use Join slide or my slide to do it in Japanese or English. So maybe you might think you don't need a quantum computer to solve that problem, but I decided, well, I had 270 pages. I decided I won't be able to do that in 20 minutes, so I'm going to use Jung's slide. And I was preparing in English, but after returning from a business trip, the organizer asked me to do it in Japanese. So I switched to Japanese. So another option was available, that is run away. But I decided not to, and I made an effort to come here. I think number of qubits has increased, even if with a large number of qubits, that option of running away, maybe the computer will not be able to propose that. So Valuenex was established 2006. So I quit working for a company, and I started this company in 2006. So I wanted to visualize big data and gain knowledge from that. And so that's what we do. And so there's white space or dark data. So where there is no information, you can find information. So on the internet, 50 zettabytes of data, vast amount of data is available. But when you use the search engines or SNS, there's this filter bubble, and we're trapped in the filter bubble. We're not able to access all that data. And within the filter bubble, the information, well, the information that you send out returns to you. It's like an echo chamber. You think that you're looking at the world, but you're actually looking at the very small slice of it. In 2025, very soon, that will increase to 75 zettabytes. And so data is increasing, to a volume that cannot be handled. So how to do optimization in that kind of environment? You will need quantum computing to do that. And so our customers, and these are the companies that agreed to be disclosed. So technological data, market data, they combine that, and they are trying to find the seeds for the next strategy. Why is that necessary? It's because I think you hear it in many corners. Past 5 years, next 5 years is going to be completely different. And Moore's law is going to end. Fujitsu speaker said. So there is a limit to miniaturization, but the volume of data continues to increase. So Moore's law itself actually survives. And what will happen in the next 5 years is what happened in the past century may happen in the next 5 years. From 1960, so in 2020, it was inflection point, and they said, and something that was unexpected should happen around 2020. People said in 2012, well, there was a pandemic, there was a war, so things that we never imagined. Things that happen only once in a decade or two happened one after another. So you can't just decide based on experience. You have to look at the bird's eye view. You have to look at the objective view, and you have to have a different perspective and make decisions in this kind of a world. So in 2006, when I established a company, the company name was Sochi, meaning create knowledge, and I felt that was a great name. At that time, well, there were most of the startups had English names, alphabet names, and I like the name Sochi with two Chinese characters. But when I go to Taiwan and China, and people liked it so much that they imitated And so there are many such companies in Taiwan. But when I went to Silicon Valley and I said, we're Sochi, and people can't pronounce, I write it as SO-TI, and they thought it was a joint venture between Sony and Texas Instruments. So I decided to change the name to Valuenex, next value. Why didn't we say Valuenext? Well, the domain name was already taken, so we call it Valuenex. So you have this kind of a picture, and it's like a contoured diagram, but you have many dots inside, and the relationship between the dots that is accurately portrayed in 2D. So patent document, let's say there's 100,000. So it's a relationship between 100,000 times 100,000 is 5 billion. So 5 billion relationships, to visualize that in 2D is actually quite difficult. Well, the patent document is usually about 10 pages A4, and 100,000 of that means 10 of millions of words. So based on that, you look at the two-dimensional relationship, and that's a lot of computation. That's why we're interested in quantum computing. To do the optimization, how to accelerate that has been a pain point for us. So in terms of algorithm, we've modified it so that if it's 10,000 cases, we can do it in several tens of minutes. And even with 100,000, we can do it in several hours. Still, it's not real time. If it becomes real time, a different world will appear. But now it's batch processing. Our customers, however, fortunately, they don't necessarily need real-time analysis. They actually want a more accurate map. Based on that map, they want to make decision. So most of our customers have that mission. So as of now, it's not a problem. But if this becomes possible real-time, then the 75 zettabyte, 100 zettabyte, or bigger world, and you'll be able to know what's happening in the world accurately, make decisions accurately if we can do this real-time. And what we say is the objectivity and accuracy and the bird's eye view. You need to be objective, and you have to have a full view, no leaks, and accuracy. That's most difficult. I don't think you will understand if I explain the algorithm. And so you want to confirm the relationship by asking the customer to check, but that takes time. So accuracy, as we see it, well, mathematically, there is the approximation and optimization, and I think quantum computing looks at the optimal solution. And in finance, you need exact solution, and approximation you need for a strategy. And so you have to find the best solution, but it cannot be exact. And the optimized solution is the best you can find in the as-is situation. So that's what we're looking for, and so I think we have very good affinity with quantum computing, and we're waiting for it to be completed. We're waiting with anticipation. We're very happy that we've been invited, and with Kyushuya-san in Palo Alto, I had a talk, and this led to me speaking here. And so this was made by John Choi, and I think he's brave. So they made these charts using the patents owned by these companies. So it shows the strengths and weaknesses of each company, and it's going to be shown here. And he's not here, so I have to say it. So what you can see from this is that you create this kind of chart concerning quantum computing. So we used patent data. So where is that data? Where is patent filed by which company in which area? If there's overlap, means there's competition. If it's disparate, it's unique. And you can look the change over time to see how it's evolving. So that's what we did. So in the U.S., we look at the patent data for quantum computing. There's about 37 million, or 30, or rather 3,384 different ways of counting. So about 3,400, and you can see recently it's been increasing rapidly. So quantum computing itself has a long history, but in terms of papers, the trend emerges earlier. But with patents, it's after commercialization, so it's recently been increasing. And so this may be hard for your eyes, so let me explain how it works. So you have these dots, and one dot is one patent information. So how close is the content of the patent? That determines the distance. There's no vertical horizontal axis. It's just a relative relationship, and you seek an optimal solution, and this is the what you get. And so where it's dense, where there are many patents, you have darker color like red. Where there are less, it will be blue. So that's how it's made. And so automatically it's labeled. And we've modified it just a bit for this presentation. But where you see these peaks, you can see what the peaks are. And I think you're familiar with many of these terms. I think there are many ways to express this. Technical terms, a lot of them are used in this field. So you can make a list or chart. And you can do a bingo with these technical terms. That was impressive. That's one way. But our approach is to look at the technical fields and see how close they are to each other. And so company A and B, maybe they're doing the same thing, but the way they name it, they call it, is different. But then on this chart, it will show up on the same place. And so maybe you use a vague expression or different name to conceal it to your competitors. But if you look at the patent document, it becomes clear what you're doing. And so we separate it, break it up in each word, and we look at the frequency and we do a calculation. And this is what you get. And this takes a lot of time based on morpheme analysis. And so we provide this on the web, and we provide professional service. And so for about 20 years, I've been doing these kinds of charts. And so I can see that in an instant that this is still early stage. It's clear if you do it with papers. So you have many islands, and you have alternative technologies, not much standardization. That is what you see from here, interpret from here. And then you see two groups and no connection between the two. So quantum computing, for it to be completed, it has to be connected in a series. That's not completed yet. These are patent information, so know-how and the various things that you need to conceal doesn't appear. It's dark data. But you can see that the research element is still strong here. Now, let's look at this as a trend. Past 5 years, it's been increasing. So it's not meaningful to go back too much in time. 2010 was like here, and then 2022, it's moving to the upper left. What this trend shows is that in each year, the center of R&D is shifting. Well, so you connect the dots of the center of R&D. So you can see that this is moving from lower right to upper left. So in quantum computing, looking at the patents, this is the current situation. And so lower right is research, and around here is hardware-related research. And this is software, including algorithm. And the upper left is application. And solving optimization problems around here. So Valuenex, if it has some kind of patent or a service, it would be around here. And you see that there's not much activity there. So the problem is that this center is empty. And this recalls another field, 2014. Micro LED technology, LuxView, was acquired by Apple at quite a high price. At that time, there was separation between material and device, and LuxView connected the two. Was the single company that had the technology to connect that. And I don't know how Apple came to recognize that, but if you take this kind of a view, you can see that. And also in autonomous driving, NVIDIA is here today. The camera technology and the automotive technology, automated braking technology, it was two separate groups of technologies, nothing compared to two. That's the control technology. And in that space, a certain company entered and established a strong position. So in quantum computing as well, right here, right around here, who is going to dominate here is going to be a key battle. And from here, I'm going to have to speed up. So IBM have this kind of distribution, separated into two blocks, software and hardware, and closer to research. And within IBM, there's a key person of this person who has filed many patents within IBM, and you look at that person's patents, it's centered around here. So this person, you can surmise, is the central key player at IBM, at Google, very strong in deep learning related areas, but too widely spread out. And like so, and Microsoft, completely separated into three blocks, nothing in the middle. So they're going to have to depend on someone else for that center. And then dedicated companies, of course, they will be focused in one area. D-Wave, I think you can see that they're closest to standardization because they have the center and they're in a position they can spread out to left and right. And you can see this company, and they have their specialty company. They focus on their strengths. Of course, that's a viable strategy. Let's look at Japanese companies, NEC and Fujitsu. Fujitsu, well, they had a presentation, and they explained that they work broadly. But looking at the patents, they're really focused, and they have strengths in this particular area. But the research is not reflected here, just patents. So you have to look at both papers and the patents to see in which areas companies have knowledge. This is a little difficult to see, but this shows you who is competing with whom. And so where there is a lot of overlap means that there is competition. Now, it's not that just because it's overlap, it's bad. If you have a good position and you have overlap, then you can have a good alliance. It's like offsetting. So there are several offsetting combinations that can come out of this. And finally, so that using that kind of data and combining with some other data, you can have more accurate understanding about the current state of development and their allocation. So today I used patents, but research is stronger now. So maybe use papers or use newspaper articles from market perspective. Using all of that can clarify the relationship further. Then find the vacuum. And if you're going to do a startup, you maybe focus on that vacuum. and then you'll be able to compete with the mega players, perhaps. Thank you for your attention.